Hey guys, Mr. Gran here, 8.3, adding and subtracting rational expressions. So in this video, we are going to add and subtract rational expressions. Okay, so before we do this, let's just review a little bit about how we actually add and subtract fractions, because that's what we're doing. We're adding and subtracting fractions, but they're big fractions with equations in them. So looking at something like this, right? 1/5 plus 3/5. That fifth is like a label, almost, right? You don't add the denominators together. The denominators stay the same. If I have 1/5 and I add 3/5, how many fifths do I have? That many, 4. Same thing with subtraction. 6/7 minus 4/7. If I start with 6 of something, I subtract 4 of something, I'm left with 2 of something. And what is that something? A 7th. All right, so how does that affect adding or subtracting rationals? Well, it's really the same thing. It's just a little more complicated because these are like, adult fractions. All right, so we're going to create a common denominator if needed. So the example in this video, we're actually not going to need to make a common factor. We'll start out with ones that have a common factor. But we're going to factor the denominators, right? Just the denominators in this case. We're just going to try to get the denominators to match, so that's really all we're focused on at first. All right. Then we're going to multiply by any missing factors. That's how we're going to create a common denominator. Then we're going to combine the numerators, meaning that we're either adding or subtracting what's on top after we made a common denominator. And then we'll simplify if possible and list any restrictions. So domain restrictions will again be a thing in these problems. All right, so our first example. Add or subtract, identify the x values for which it's undefined. With this one, the denominators are already common, right? So all I need to do there is just combine like terms, basically. So if I do that, this is going to be a fraction over the common denominator x plus 4. And now I've got x plus x, which makes 2x, and I've got -3 plus a -2, which makes a -5. And that's all it was for this one. What can't x equal? The denominator would be 0 if x were equal to -4. All right, a little more complicated now that it's a minus. Sometimes what I like to do with these is once I've established what that I have a common denominator, I'm going to distribute that minus to all of these. So I'm going to change it to a plus, but that's going to be a negative 2x squared. This is going to then be a plus 3x, and this is going to be a plus 2, right? Because it's plus, and then we change the sign of everything on top. Okay. Everything is over the common denominator 3x minus 1. And now I just have to combine my like terms. 3x squared minus 2x squared is 1x squared. I only have this plus 3x on top, so nothing to combine with it. And then I've got a -5 and a plus 2. That makes a -3. What is our domain restriction? What can't x equal? Well, it's a 3x minus 1. I can't just change the sign. Maybe I figured out some shortcuts, but if not, set it equal to 0 and solve for x. X can't equal 1/3. All right, go ahead and try these two. Pause the video, and when you're ready, check your work. All right, our first one here, again, common denominator already, so I don't have to worry about anything there. It's going to be over x plus 2, and then I'm just combining like terms. So 3 plus 4 for the x's is 7x. And then a -4 plus 7 is a plus 3. And what can't x equal? X cannot equal a -2. All right, our next one, it's subtraction. So again, I like to start out by making it plus a negative. I'm going to change the signs. The denominators are already the same again. So it's going to be a fraction over 2x minus 5. Combine like terms. X squared minus 4x squared is minus 3x squared. 7x is the only, I've got nothing to combine with it. And then minus 3 minus 12 is minus 15. What can't x equal? Again, we could set the denominator equal to 0 and solve. X can't equal 5 over 2.